Guys, welcome to my YouTube channel. You are still tuning in to my YouTube channel whereby we bring you the best of maths, physics, and chemistry. Guys, my YouTube channel, Easy Teach, will always be there for all the grade 12s that will be writing their exams. So guys, please feel free and ask questions in the comment section if you have any question, or you can send me an email. You can request an email on the comment section. Now, if you haven't subscribed, please go and subscribe and also click the notification button for more content. All right. Now, guys, today I'm going to be teaching you guys a very interesting topic in chemistry, electrochemistry. 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 It's a very interesting topic. Electrochemistry, sorry for that. Electrochemistry. Electrochemistry, as you can see from the term itself, we are going to deal with electricity generated by a certain chemical, or a chemical generated through electricity. Now, we have to define the following term: redox, reduction, and oxidation. This is reduction and oxidation reactions. Now, what is reduction and what is oxidation? Now, oxidation is the loss of electrons. That's oxidation. And hence Leo. So to remember what oxidation is, we use the term Leo. And for reduction, GER, gain of electron, that is reduction. Now, what are substances that, now the substances that are oxidized, an oxidized substance is a reducing agent. Same apply with a reduced substance. If a substance is reduced, then that is reduced is a oxidizing agent. All right. Now, we have the so-called anode and cathode. Now, on the anode, this is where oxidation takes place. The cathode reduction takes place. All right. Now, a cathode and an anode, these two are called electrodes. These are electrodes. Electrodes. Now, electrodes, they conduct electricity. Now, these two elements are used in cells. They're used in batteries. They're used in batteries, or the so-called galvanic cells, so that they can conduct the current inside the cell. We're going to talk about them in details later on. So we have electrode, and we also have electrolyte. Now, the electrolyte is a solution. It's a solution that contains ions, and those ions conduct electricity. So as we have explained, or as I have highlighted on the term electrochemistry, there's a term chemistry, and that chemistry shows that there is a certain chemical that is conducting electricity. That chemical is an electrode. It's an electrolyte, sorry. It is an electrolyte, and also the electro part represents the anode and the cathode. All right. Now, we have two types of cells. We have two types of cells. We have electrolytic cell and voltaic or galvanic cell. Now, electrolytic cell, hence the name says. Now, electrolytic comes from electrolysis, and electrolysis is using electricity to split a certain chemical. So an electrolytic cell will look like that. There is an electrode, there is another electrode, and this is a solution. So basically we use energy. We use the battery to split the chemical into two different chemicals. Whereas with voltaic cell, here energy is generated. Here, electricity is generated. This one uses electricity and this one generates electricity. They both have electrodes. However, this one always have two separate compartments. And those compartments have two different solutions. And those two different solutions, there's a connecting element which we call the salt bridge. This is an electrode and this is an electrode. Now, the difference between the two, let me continue highlighting. Now, with this one, electric energy is converted to chemical. Whereas with this one, chemical is converted to electrical. Right. The second point is no salt bridge. There's a salt bridge. This one is non-spontaneous, meaning it cannot initiate itself, but it needs energy, and that energy is supplied by the battery. So it's not spontaneous. It can't start itself without energy. And this one is spontaneous. So it's chemicals reacting so that they can produce electricity by themselves. All right. The next point is now the electromotive force, or the EMF. EMF is always negative. It is always negative. Later on, you will see how we calculate EMF. EMF. So we're going to calculate EMF from the reduction table. EMF given by, it is always positive. Right? Now with this one, with the electrolytic cell, what we know is that negative ions move to the anode. Where they are oxidized. Whereas with the galvanic cell, what we know is that oxidation half reaction occurs at the anode. Okay. The other key thing to note is that normally if the halides your chloride, your bromium, etc. If they are available in the solution, they will be oxidized first. Ions, all right. Now, with a galvanic cell, for an example, we will have half reactions. And what we know is that strong reducing agent is oxidized. Now, how do we know that certain chemical is a strong reducing agent? We have a reduction table, which I'm not going to display right now. On the next segment, when we do examples, I'm going to show you the reducing the table of reduction. Now, for instance, I'm going to show two half reactions that may take place inside the half cells. Let's say, for instance, zinc oxidizing on, let's see, I'm going to look for my reduction table so that I can be sure of what I am doing. I want to be sure of what I am doing. All the calculations must be correct. Now, I just want to look if I don't find it, it's fine. But zinc of reaction, we will have two electrons. It ends there. All right. What you will notice is that zinc has a tendency of losing electrons as compared to copper. Those are two half reactions. Now your net will be right. Now, guys, I'm going to end there, and I will continue with part 2 of this segment. Now, guys, if you haven't subscribed, please do so that you can get more upcoming content. Thanks, guys.